Hi, welcome back to my YouTube channel. Please do go to subscribe to Massa Tutorials so that whenever I post any video, you'll be the first to receive it. Alright, now we are still on our GHS topic, change of subjects. Under the topic, we have the subtopic, relations involving fractions. Relations involving fractions. Relations involving fractions. You know what a fraction is? A fraction is part of a whole number, right? So now, let's proceed. So relations involving fractions. Whenever any relation involving fractions is given, we first multiply each term in the relation by the what? LCM of the denominators. Again, whenever any relation involving fractions is given, we first multiply each term in the relation by the LCM of the what? Denominators. Of the denominators. We can call them as what? Divisors. Divisors. So whenever any relation involving fractions is given, we first multiply each term. I believe I told you all, we said what a term is, right? A term, how can you determine or how can you find for what? A term. A term, you can find for a term when what? When the operation sign or when each number or variable is separated by what? An operational what? Sign. When each variable or each value is what? Separated by what? An operational sign. So that's what? A term. A term. So in the relation by the what? LCM. And you know the full meaning of LCM. Least common multiples or lowest common multiples. Least common multiples or lowest common multiples of the denominators known as what? The divisors. The divisors. So now let's wrap up. So if you have any fraction, you have to what? Multiply each term in the relation by what? The LCM of the denominators. Do you understand that? Alright, let's wrap up and see. Alright, so an example. An example. Alright, we have this example here. Given that L equals 2r plus 1 over 2 pi r. Given that L equals 2r plus 1 over 2 pi r. Make pi the subject of the relation. Make pi the subject of the relation. Now, so L equals 2r plus 1 over 2 pi r. See that? Making a variable the subject means what? To what? To let the variable stand on its own. To let the variable stand on its own. So now L is being made what? The subject here. L is being made the subject here. Now how many terms are here? How many terms? Yes, I told you that what? 10. So if you want to find for the number of terms, the variable or the value is being separated by what? The operation what? Sign. So now we have equal sign is being separated by what? We have L and 2r, sorry, is being separated by this one, equal sign. Then we have plus is being separated, we have 2r, then 1 on 2 pi r is being separated by this what? Addition what? Sign here. So now how many terms here? We have 1 term, 2 terms, then 3 terms. Now 1 on 2 is multiplying what? Pi. At the same time multiplying what? R. So they are together as 1 because they are multiplying what? Itself here, right? So they are together as 1. Alright, so now let's see. We want to make what? Pi the subject. Now we have two methods here, so you don't worry. I'll give you all the two methods. How you can solve this question very easy. Now method 1. Let's go to method 1. Method 1. Here, L is divided on what? 1. The divisor for L is what? 1. Equals 2R is on what? 1. Then plus we have 1 on 2 pi what? R. Right. Now, 1 on 2 pi R can also be written as what? Pi R all on what? 2 is the same thing. Pi R all on what? 2 is the same thing. Because 1 on 2 times pi R, this one is on what? 1. Now, this one becomes what? Multiplication of what? Fractions. So, if you want to multiply fraction, what do? You multiply the numerators at the same time, you multiply what? The denominators. So I have 1 times pi r, which is what? Pi r. Pi r, the invisible value or the invisible number here is what? 1. All on 2 times 1 is what? 2. So it's the same thing as pi r on 2. Alright, so now let's proceed. Now, we have fractions here, right? So now we have to determine our LCM, the lowest common multiple. Now, the LCM of 1 and 2 is what? 2, right? Alright. Why? Because 1 goes into 2 how many times? How many times? 1 times 2 gives you what? 2. So 1 goes into 2 how many times? 2 times. 2 times. So now, our LCM here, our lowest common multiple, we will use what? 2. So now, how many times here? 3 times. So we multiply the LCM by what? Each what? 10. So I have 2 times L, which is the same thing as L on what? 1. Equals 2 times 2R plus 2 times 1 on 2 pi R. Are you watching? Alright. We are proceeding. 2 times L gives 2L equals 2 times 2R is what? 4R. Why? 2 times 2 is 4. Then 9R. Then plus, these 2 cancels these 2. Right. So we have 1. 1 times 1 is 1. Then I have my pi R. You don't have to write 1 again because pi R is the same thing as what? 1. We have 1, an invisible number there, so there is no need to write what? 1. Alright, so now we want to make pi the subject. Now you can see that 4r or pi r, pi r is adding itself to what? 4r. So now we are adding. I want pi. I have to first what? Eliminate this guy here. So I have to send this 4r to the what? Left hand side. This 4r here is what? Positive. So when it crosses the equal sign, it becomes what? Negative. So I have 2L minus 4R equals pi R. Equals pi R. Now, again, 2L minus 4R equals what? Pi R. So what can we do here? We can divide both sides by the coefficient of pi, which is what? R. It's the same thing. So we divide both sides by what? R. Okay. So we want what? Pi. Now here, they are what? They are multiplying here, right? They are multiplying. So in order for you to get what? Pi, you have to what? Divide. Because here they are what? Together. They are together. You don't have to send R to the left hand side and tell me that it is negative. No, it is wrong. Here they are multiplying, so in order for you to get pi, you have to what? Divide. So I have 2L minus 4R all on what? R equals pi R all on what? R. So R cancels what? R. Right. So now, what do we do again? We have what? Pi being equal to what? 2L minus 4R all on what? R. Now this one you can do further simplification here. which is what? Pi equals 2L. I told that this divisor is what? 2L. At the same time, this divisor is what? 4R. Now, we can cancel. R cancels what? R. Then we have pi being equal to 2L on R minus 4. So, this is the further simplification for pi. So, here, we've made what? Pi to stand on its own. Pi to stand on its own. Now, here, watch it. You cannot cancel R by this R. It's wrong. You have to do it like what I've taught you here. So it means that R is for what? 2L. At the same time, R is for what? Negative 4R. It's the same thing. When you do it like that, then that means you can cancel what? R, then this R. Alright, so that's the first method. So watch it very carefully. Alright, let's proceed. Let's proceed to the second method, or method 2. Method 2. You have L equals 2R plus 1 on 2 pi R. So now, we want what? Pi. You can send this 2R to the what? Left hand side. Because this one is positive. I always tell you that the variable you want to make what? The subject. Make sure that the variable is what? Positive. And also the variable must be at the what? Left hand side of the equal sign. The variable must be at the left hand side of the equal sign. So now, since 1 on 2 pi R is adding itself to what? 2R, we can send this 2R to the what? Left hand side. So I have L minus 2R, because here is what? Positive 2R. When it crosses the equal sign, it becomes what? Negative 2R equals half pi R. Please, you understand that? Alright, so we can proceed as L minus 2R equals 1 on 2 pi R. Now, this one is on 1, this on 1, right? So our LCM is what? Is 2. So we multiply 2 by what? The LCM. So how many times here? 1, 2, then what? 3. So we have 3 terms there. So we multiply 2 times L, then minus 2 times 2R equals 2 times 1 on 2 pi R. So this one cancels. So I have what? 2L minus what? 4R equals what? Pi R. Right? So now, we want what? Pi. So what do? We divide both sides by what? R. So I have 2L minus 4R all on what? R equals pi R all on what? R. So this one cancels, right? So pi gives us 2L minus 4R all on what? R. So now you can do your further simplification here, which is pi equals 2L on R minus 4R on R. So R cancels what? R. So I'll get pi being equal to 2L on R minus 4. So that's that. So you can go by this, or you can go by the first method. It's the same thing. If you do it and do it well, you all get what? The same answer or the same results. So kindly watch it very carefully. Alright, let's proceed with the next example. So here, the question can be twisted as shown on the board here. The question can be twisted as shown on the board. Given that r equals half a plus b, then k. Find k in terms of r, a and b. Find k in terms of r, a and b. So now watch here. If you want to find k in terms of r, a and b, what's the meaning? It means that you make k the subject. Make k to stand on its own. So let's see. Solution. So I have r equals half a plus b k. Now, we have the denominator, which is what? 2. Then this one is on what? 1. Right. How many times here? 1 10, then what? 2 times. Because they are what? Together. They are together. 1 on 2 is multiplying this expression inside the bracket, which is what? A plus b. Then at the same time, k is multiplying what? A plus b, then multiplying what? Half. It's the same thing. Half is multiplying a plus b, then k. Then k2 is multiplying a plus b, then what? Half. So if you go like this, then if someone goes like this, you all get what? The same answer. So now we have 2 terms here, and the LCM is what? 2, still 2 here. So LCM, we have what? We have it to be 2. So I'll multiply here by the LCM, which is 2, equals 2 times half, then a plus b k. If you locate the number of terms, then it will be very, very simple. Alright, so please watch how we locate what? The number of terms in an equation or in a relation. So 2 cancels what? 2, right? 2 times r gives 2r equals 1 is multiplying a plus b then k. It's the same thing as a plus b what? K, right? So now we have what? We are making k the subject. We are making k the subject. Find k in terms of r, a and b. So now we have k here, right? K is multiplying this expression a plus b. Since they are multiplying, since a plus b is multiplying itself towards k, then I can divide both sides by what? A plus b. Again, since a plus b is multiplying itself to k, then I can divide both sides by what? A plus b, because they are what? Together. So if I want k, then I have to separate them. So I have 2r all on a plus b equals a plus b, then k, then I have a plus b. So this one cancels that, right? So I have k being equal to 2r all on a plus b. So we found for k here. So in terms of, find k in terms of what? R, a and what? B. Find k in terms of r, a and b. So it means that make sure that r and a and b will appear inside your what? Inside your relation. So I have one question as that being twisted. I'll drop it so that you solve it, then either you call or you drop it at the comment section so that I attend to you. Alright, so that's how we make what? K the subject. K equals 2r all on what? A plus b. Alright. Next example. Next example. We are dealing with relations involving fractions. Relations involving fractions. So next example. If I have 1 on r equals 1 on r1 plus 1 on r2. Make r1 the subject. Make R1 the subject. So we have this. They said we should make R1 the subject. Now R is different from what? R1. Then R1 is different from what? R2. So we make R1 the subject. Now, solution. How do we make R1 the subject? We have fractions here. Fraction, fraction. So what's here? How many times? 1 on R equals 1 on R1 plus 1 on R2. How many times here? Here, these two fractions are separated by what? This sign here, operation sign here. So we have 2 times here. Then these two fractions are separated by this equal sign. So we have what? 1 term at the what? Left hand side. So 1 term at the left hand side, 2 terms at the what? Right hand side. So we have how many terms? 1, 2, then what? 3. 3 terms in all. So how do we find for the LCM? The LCM, look at how I'm finding for the LCM. R, we multiply R by this R1, then by what? R2. Again, how do we find for the LCM? LCM equals what? R times R1 times R2, which is equal to what? R1, R2. So LCM is what? R1, R2. So we are multiplying this LCM R1, R2 by what? Each term. So I have R1, R2 times 1 on R equals R1, R2 times 1 on R1. Then plus, let me continue here. R1, R2 times 1 on R2. So we have R1, R2 times 1 on R1 equals R1, R2 times 1 on R1 plus R1, R2 times 1 on R2. So now we can see that this R cancels what? R. R1 cancels R1, R2 cancels what? R2. Very, very simple. So now we have what? R1, R2 being multiplied by 1. That is the same thing as what? R1, R2, which is equal to R2 times 1, which is the same thing as that. Then plus R1 to R1. Please, do you understand that? I believe you are following. Alright, so R1, R2 equals R2 plus R1. We are making R1 the subject. So now watch here. I believe you do remember on our last video, we said that here we have what? R1. Also, we have what? R1 here. So we have to group them what? Aside. We have R1, R1. Here, this R1 here, R1, R2, they are what? Positive. Then this one is what? Positive. So when it's coming, it will be negative. So it doesn't worry at all. So this one, I'll group them. So I have R1, R2 minus R1, which is equal to R2. Very, very simple. R1, R2 minus R1 equals R2. So now, what do? We have to factorize. We have to bring out R1. So R1 out. Then we have what? R2 minus R, which is equal to R2. R2. I told you that factorization is the reverse of what? Expansion. So make sure that when we are done factorizing, when you multiply R1 by R2 and R1 by negative R, you have to get back to R1, R2 minus R1. Factorization is the reverse of what? Expansion. So now we want R1. So what do? Since R1 is multiplying itself to this expression, R2 minus R, we cannot separate them by what? Dividing. So I have R1, R2 minus R, all on R2 minus R equals R2 all on R2 minus R. So this one cancels, right? So I have R1, which is equal to R2 all on R2 minus R. So that's R1, the subject. So that's how to make R1 the subject. So you know what? You can try and make either R or R2 the subject. Try. If you have any problem, call. Try and make R or R2 the subject. So use the same procedure. When you get to where you want R, make sure to group them. Then you factorize R out. So make sure to group them at one side, then factorize R out. So if you have any problem, call 05410864890, 05410864890, so that I'll attend to you early. Alright, so make sure that you make R and also make R2 the subject of the relation. I believe you can do it. So try. So watch how the process went. Then watch it very carefully. Then analyze it. Another example on that. Let's see. We have 1 on C equals 1 on C1 plus 1 on C2. 1 on C equals 1 on C1 plus 1 on C2. 1 on C equals 1 on C1 plus 1 on C2. So this time, make C the subject. Or somebody can say express C in terms of what? C1 and C2. Express C in terms of what? C1 and what? C2. So now, solution. So, what do we do? 1 on C equals 1 on C1 plus 1 on C2. First of all, you have to what? Clear the denominators by what? Multiplying each term by the LCM. How do we find for the LCM? I said if you want to find for the LCM, multiply each of the denominators. Multiply all the denominators we have. We have C, C1, then what? C2. So LCM can be found as C times C1 times C2, which is equal to C, C1, C2. Is it okay? Alright, so I have C, C1, C2 times 1 on C equals C, C1, C2 times 1 on C1, then plus C, C1, C2 times 1 on C2. So that's the LCM. C, C1, C2. As the LCM. So now you can cancel C, C out, C1, C1 out, C2, C2 out. Right? Okay. So we are left with what? C1, C2 multiplied by what? 1. It's the same thing as C1, C2, which is equal to C, C2 multiplied by 1, which is C, C2, then plus C, C1, which is multiplied by 1, which is the same thing as C, C1. So now, we want to make C the subject. Now here, there is no C. Here there is C1, C2. We don't have C. Here we have C. Then here also we have what? C. So it has been grouped what already. It It has been grouped already. So what do we have to do? Fast, we have to factorize. Factorize, bring out C. So C1, C2, which is equal to C out. We have C2 plus C1. I told you that factorization is the reverse of what? Expansion. So make sure that when you factorize, make sure that you have to multiply what back in order for you to get your expression, which is CC2 plus CC1. So now I have C1, C2, which is equal to CC2 plus C1. So what we have to do here? We have to what? Divide both sides by what? C2 plus what? C1. Since this C is multiplying this what? Expression inside the bracket. So we have C2 plus C1. Then here C2 plus C1. So this one cancels. So I have C, which is equal to C1, C2, all on what? C2 plus what? C1. So therefore, C equals what? C1, C2, all on what? C2 plus C1. So please try and what? Make C1 or C2 the subject. Try and make C1 or C2 the subject. It's the same thing we just did. So don't worry, it's very, very simple. So check the process, the procedures used in solving this question. Alright, next example. I want you to understand it. So tell yourself, I will understand change of subject. Very, very simple. Very, very simple. You are dealing with it one after the other. Paste by paste by paste. Alright, so now let's proceed. Let's see 1 or 2 or 3 examples. I have 1 on F equals 1 on U plus 1 on V. We are making U the subject. So we want to make U. Letter U. The variable circled is what we are making. So you can pause the video, then make this variable U or letter U as the subject. Alright, let's proceed. So we have to find for what? The LCM. How do we find for the LCM? By what? Multiplying through, by multiplying the denominator. So LCM equals F times U times V, which is equal to FUV. Which is equal to FUV. Very, very simple. Very, very, very simple. Now, how many times? 1 term, 2 terms, then 3 times. So we have to what? Multiply each term by the what? LCM. So I have FUV multiplied by 1 on F, then equals FUV multiplied by 1 on U, then plus FUV multiplied by 1 on V. So this F cancels, that's F. U cancels what? U. V cancels what? V. So I have UV multiplied by 1, which is what? UV equals FV times 1, which is what? FV. Then plus FU multiplied by 1 is what? FU. Very, very simple. GHS 3 topic. Change of subjects. Very, very simple. Now, what do we do here? We want to make U the subject. So now, watch here. We have U here. Then U here. So, U. What do we do? Yes, tell me. We would group like terms. So this one is positive FU. Immediately this positive FU crosses the equal sign, it becomes what? Negative FU. So I have UV minus FU equals FV V. What do we do again? Yes, you factorize out, bring out the variable u. So u out, we have what? V minus what? F equals what? FV. So now this u is multiplying the expression inside the bracket, which is what? V minus what? F. So we have to divide both sides by what? V minus F. So I have u and V minus F equals what? FV. So I have V minus F, then here V minus F. So this one cancels, right? Which is what? U equals what? FV all on V minus F. So U equals what? FV all on what? V minus F. So that's very, very simple. Change of subject. Relations involving fractions. So watch the steps very, very well. Good luck. Alright, our last example on relations involving fractions. Please, if you want to be perfect in mathematics, please soil your hands with more mathematical problems. Soil your hands with more mathematical problems. Every day when you are sleeping, mathematics. When you are dancing, mathematics. When you are crying, mathematics. When you are laughing, mathematics. Everything must be what? Mathematics. So soil your hands. We are not perfect, but we are all trying to be what? Perfect. So please learn hard. Always learn. You pass. Very, very excellent. You come out with flying colors in mathematics. So please learn hard. This year's PC say I will pass. So you pass. Don't worry. Our last example then. We proceed. So 1 on K equals 1 on K1 plus 1 on K2. 1 on K equals 1 on K1 plus 1 on K2. So we want to make K2 the subject. We want to make K2 the subject. K2 the subject. Now what do? We have to find for what? The LCM. Ask yourself how many terms? Yes, 3 terms. So 1 term, 2 term, then 3 times. We have 3 terms. Now LCM, which is what? Multiplying the what? Denominator. So K times K1 times K2, which gives us K1, K2. Very, very simple. So now we have to multiply each term by what? This LCM. So I have K1, K2 times 1 on K equals K1, K2 times 1 on K1, then plus K1, K2 times 1 on K2. So this K cancels what? K. K1 cancels K1, K2 cancels what? K2. So I have K1, K2 times 1, which is what? K1, K2 equals K2 multiplied by 1, which is K2, then plus K1, K1. So now we are making what? K2 the subject. So now we have K2 here, then K2 there. What do? We have to what? Group like terms. So this one is positive. When a value or a variable stands on its own without any sign attached to it, then that means that value or variable we are talking about is what? It's a positive what? Value or variable. It's a positive value. So if I have a number 3, then there is no sign in front, then that means this one is a positive 3. X. There is no sign in front, then that means it's a positive variable x. Alright, so we group like terms, which is K1, K2 minus K2 equals K1. Right. So now what do? We have to what? factorize. Factorization is the reverse of expansion. So we want K2, so K2 out, you get what? K1 minus what? K, which is equal to K1. Alright, so what do we do? K2 is multiplying itself. K2 is multiplying the expression K1 minus what? K2. So they are multiplying, then that means they are what? 1. So we cannot divide them. So which is K2, K1 minus K, which is equal to K1. So here K1 minus K, and here K1 minus K. So this one cancels that. So I have what? K2 equals K1 all on what? K1 minus what? K. So K2 equals K1 all on what? K1 minus K. Very, very simple. Very, very simple. So relations involving fractions. So let me give you nice and superb assignments so that you try. Make sure that you try them. Try them yourselves. And try them yourself. Do you understand that? Get the feel, the figure, the enthusiasm, then write it, solve it very, very well. Sit down on your bottles, solve them. You get there. It's a gradual process, so you get there. Don't worry. Alright, so watch it very carefully so that I clean the board. Question 1. Make A on X the subject for this one. Now we are making what? A on X. A on X the subject. That means we want a fraction as the subject. So try. So I have X being equal to M plus E all on M minus E. Again, question 2. Make X on A the subject. Make X on A the subject, which is X equals M minus E all on M plus E. 3. Make N the subject. Make N the subject, which is 1 on N equals 1 on M. 4th question. Make U the subject. So we are making U the subject. Which is S equals H on 2U plus V. S equals H on 2U plus V. Then last example, last assignment question. Make U the subject. So we have S equals 2U plus 80 all on 2 multiplied by T. So try them yourself. Alright, we've come to an end of this lesson, this subtopic. relations involving fractions. So our next time we meet, we'll talk about what? Relations involving root signs, right? Square root, cube root, then and so on and so forth. You have the fourth root, the fifth root, the sixth root. How will you solve questions involving that? Now, please try them. Make sure to analyze them properly. Then drop it at the comment section. I will attend to you. Alright. Or if you have any discussion with me, you can call 05410 Massa Tutorials is there for you. Please subscribe to my channel, like and share my videos. We shall meet on our next